Hello everyone, good morning. Just drop a hi if you can able to see me and my voice is audible. Can I just get a basically yes or everything is fine from the technical end? So, mm, so just confirm me once if my voice is fine and you're able to see whatever I'm writing and uh, basically technically there are no issues. Thanks, Praveen. Hi, good morning. Good morning, Manoj. So let us just wait till 11:05 till others can join. Okay, thanks for the confirmation, Nidhi. So we will be actually starting with logistic regression today. You should be able to see the topic. Meanwhile, if anyone has any doubt, please let me know in the comments so that we can clear it out. Okay. Hi. Good morning, Swapnil. Okay, clear all. Yeah, only preparation. You can ask that. So anyone, if they have any doubt, they can ask them in the comments. Basically, meanwhile people are joining, we will clear out the doubts from the last class. Okay. Good morning, Anand. Let us keep it here. Okay. Good morning, Ulhas. So we will start at 11:05. Meanwhile, if any of you have any doubts or anything, you can let me know. One more thing, just also write your college year of experience. Okay, one second. This is college year of experience, current job title. So just also write this about yourself. This basically will help me to understand the audience and curate all. Basically, make sure that my content is basically receptive by all the masses. So just want to make sure, like, if more of the college students are there, then we can maybe get more into about the interviews. If more experienced students are there, then I will try to include more of the experiences from a professional journey, as well as how we can challenge, like, let's say any project which we receive. So it is very important. Okay. Also, everyone, just once more, can you just confirm to me if my voice is clear and basically everything is visible? I don't want that, let's say, in between we face any technical issue. So it's good if we can sort them out if they are in the starting only. Okay. So just drop audible or audible and visible or yes, basically, so that I'm aware that okay, everything is fine there. Okay. We'll just start in a minute. Meanwhile, in the comments, you can ask if anything is there. So yeah. Also, I hope this is visible, right? What am I writing here? So just confirm me once if this is clear. If not, I think we cannot begin. So would surely love a thumbs up or a yes. Okay. So I'm sure that okay, we can begin with the same. Oops. Right? Are there no issues, or are there issues because of which you are not able to write? Can I just get a quick thumbs up if everything is fine? So all of the people who are viewing this, because if not, we will have to first call the technical team and get them clear. So I just want that, yeah, no issues should be there with respect to my voice as well as the video overall. Okay. Yeah, let us clear this. Thanks a lot for the confirmation, Anand. I hope this should be then fine for all of you. Okay. Yeah. So, ठीक है. I think then we can actually begin with today's session. Okay, so the very first thing, just a quick thing that today we'll be learning logistic regression. I hope you have seen the videos, seen the previous classes, because logistic regression intuition overall will be a lot based on how we form the intuition for linear regression. Okay, so it would be helpful if you remember the formulas as well as how and what we derived there. Okay, so those things, if everyone is clear, then we will be actually, then logistic regression should be very easy to understand. Okay, so now just few things before starting the session. So I hope all of you are aware. Okay, to access these classes, this is actually the iNeuron website in front of me, ineuron.in. Okay, so one can go there. We have amazing courses like basically taken by amazing teachers. We are also running community sessions on YouTube, so we'll show that also. Meanwhile, yeah, we can go to explore courses, community program, and you can see this course here. Highly recommended for all of you to basically enroll here. It's completely free. Okay, you won't be charged anything. Okay, so if you will just go and enroll now, let's say if you click this, then you can see all the classes here as well as the resources which I use. So resources will be here, and then along with the resources you can see that okay, what are the quizzes, assignment, and all these things. So of course these are very important to clear, because if you would be able to clear the 100% of the course here, that would be very helpful to us to provide you with a certificate. So highly recommend all of you guys that even if you're watching from YouTube, Instagram, LinkedIn, okay, or wherever place, okay, so please make sure that you are enrolling in this. If you also like the content, please share this page as well as the YouTube video link to your college, in your college, or let's say with your colleagues, so that they can also enroll and get the certificate. That would be highly beneficial to all of us. Okay, so we need to clear 100% of this course here if you want to get the certificate. That thing is very important. So we'll just quickly tell you how you can reach here. So you have to go to the iNeuron website, then you can go to explore courses. Then basically you have to go to, so you can also check out our other courses which are there. So we are taking a lot of courses in DSA, Gen AI, deep learning, full stack data science, all these things. Okay, so you have to go to community programs. Then yeah, so mine is here. You can also search by Mayank Agarwal here, basically the instructor. Then you can enroll now. Because we are logged in, ideally it would ask you to log in once. Okay, then this is our first class just on 2x. That's why I'm moving quickly. But yeah, here you can actually see all the resources, and if you go here, you can download them. Okay, so highly recommend all to do that. We'll just actually also show how you can access the classes on YouTube. So if I go here and iNeuron, so this is a live class, but you can actually go here in the live. So this is the current class which we are taking, and along with that, you can see that okay, these are the classes which we have, right? So good thing, we are doing a lot of other classes as well. Okay, so everything is basically in this thing. Okay, cool. So Kash is asking when will it get started. So Kash, we have actually already started. We have 3 classes already. Today we will be doing logistic regression, just for showing how you can access the previous class and other things, because a lot of people would be there who are joining for the first time. Okay, so now I hope everything is clear. So now we can go for session for today. Just would like to take 5 minutes to just quickly revise you guys on the last what we learned, because I think that becomes very important if anyone has any doubts or anything. So we'll just quickly carry it out that okay, what all we done. So let me clear it. Anyone has any doubts till now? Anything in what I have covered? So just one thing, to provide you the certificate, it is very important to enroll there. Okay, and along with that, any doubts or anything which you have, please feel free to basically ask in the comment section here. Would be very happy to help you in that. So yeah, this is what we have learned till now. So we started with the introduction to machine learning. Okay, we saw that okay, what machine learning actually is, how it is different from data science and data science and artificial intelligence. Basically, overall, what these 3 things comprises. So DS, because it is very much confused, versus ML versus AI. So we saw this thing. Then we saw different types of machine learning. That okay, what exactly are supervised, unsupervised, and reinforcement learning. Okay, we saw the examples which you should remember by heart, so that it is always very you are always able to recall that okay, which kind of machine learning is this is. Then next we basically saw on that okay, for the supervised machine learning, what is the process which we generally follow. So if you guys remember, I also show you the KISS DM methodology, which normally is followed like agile, and basically I think Kaizen is followed in software development. Similarly, KSTM is one of the methodology which is formed in machine learning or data science related projects. Okay, so it is very important to understand and remember that. Then we started with our first algorithm, which is a linear regression algorithm. Hopefully, this now won't be the case with you if you have taken the class. The overall intuition and overall, I would say, derivation of what exactly happens behind linear regression is little difficult for everyone to understand. So if you will see, the previous classes have gone through a very, I would say, easy route, and we have actually seen that okay, how we can get those values and get all those formulas. So hopefully this should not be the case, and you should be able to come out alive. Now, if we move forward, yeah, this is just something about me. We'll cover that. So we just saw a few data sets. It is very important to understand data. I always say that. So whatever data which you are seeing, basically, it is very important to understand on the same. Okay. So similarly, student, our data set were the same, which we actually saw for our derivations and everything. Okay, so today also actually logistic regression, we will be seeing similar kind of data set, but instead of this scores, we would just have if the student passed or failed. Okay, so it will just be a two values. Okay, so logistic regression is of course a classification algorithm. It's not a regression algorithm as in the name. We will see that. So now moving forward. Yeah, so we learned a lot about linear regression, that how it's a prediction model, how it is useful in regression problems. Then of course that we discussed all about this hypothesis function, how it is, like let's say for a particular simple regression model, how it is mx plus c, and this can actually, this part can be extended for a multiple linear regression as well. So m2x2. So these are basically your features, and these are the dependency on your feature. You can think of that basically. So we saw the slope, intercept form, and all these things, that okay, what I would say important slope and intercept have when which we get the line. Okay, and how we try to fit the best fit line. So simple linear regression we then solve with the equation which is written here. So this is their equation which is written here. 1 second. Okay, so I think I have to use the other pen. Yeah. So this is just different equation through which we write simple linear regression. Now moving forward, slope, intercept, and line forms, we saw all these things. Okay. Then we calculated the cost function. So if you remember, this was based on also on the understanding that okay, why, if let's say this is the line and these are the error, these are the points, why we are taking this square and not the absolute values or the actual values of the distance. So we saw that we have to penalize the errors. Okay. Similarly, then we defined this cost function. Then yeah, we also saw the coefficient of determination. So if all of you remember, it was r square. Just let me clear it. So it was r square, where we assume that the worst our model will perform is actually when we give out the mean values for everything. So it was nu by v. U by v, we can actually think of this. Okay, so this is what we all covered. Along with that, we covered the gradient descent algorithm, and we also saw different types of gradient descent algorithm, I would say. Okay, so maybe I can just quickly open that too. So if anyone has any doubt in this, please get them clear. That's the reason actually I'm just covering all this. Okay, so that we have a flow when we are learning something. It's not that we are starting with the topic but you don't know that okay, what all has been covered here. So this was the 1 second. This was an example which we saw that okay, we should have all the data. Okay, then we saw the gradient descent convergence algorithm. So we see that okay, how we have the, and all of this will be also useful in this logistic regression class. So please make sure that you are able to understand and remember all these things. Go back to your notes if you have made one, see the video again, because if you understand this very quickly, then it will be very easy to understand logistic regression. Like it will actually be just few changes and logistic regression will be clear. Okay, so this normally we saw that okay, how this is a parabolic function with a global this global minima. So we have to reach there only. We take a random value of slope. We also saw that how we can do that by putting del j by del m equal to 0, but why that is not feasible, because of like we saw these two equation if you remember. So highly recommended to actually remember that also, that yeah, we can solve that without gradient descent algorithm as well, but the issue is that it takes a lot of time. Computationally it is an issue. Okay, that's why we go to a gradient descent algorithm, where our aim is that yeah, we will be taking a value of slope, and then basically yeah, we will see that okay, it will converge because we are moving on the direction in which we should change this m. Okay, so this was the all about the gradient descent algorithm. I think coefficient determination I've covered. Then we learned a little bit about alpha also. So if you guys remember, let me clear this all. So this was the equation which we finalized. M nu is equals to M old minus alpha, which is our learning rate, del J by del M. Okay. So this was the equation which we finalized. The here alpha is the learning rate. So I told that how it's a hyperparameter, it can prevent us from overfitting and underfitting, and we have to experiment to see okay what value this is. Okay. So this thing is there. Now if we move forward, we also saw the types of gradient descent algorithm. Of course, I asked you not to remember them because uh, the namification might seem a little daunting, but we knew that okay, what exactly is happening is that if this is our algorithm, so we change our M old to this M new. Okay. So now we saw that okay, when we change this value of M, if we change this after going through all the points in our training data set, then it's a normal vanilla or basically your batch gradient descent. Okay. If we do the same after every point, so let's say we have 10 students and for each student, after each student, we are changing this value, then it's a basically a stochastic gradient descent. And let's say if we are combining our data in a manageable groups, training data, let's say we take five groups, okay, five student as a group, then we will be changing our slope 2 times. Okay, so that will actually be for let's say 10 students are there. So first we will see the first 5, then change our slope to this M new, and similarly for the other thing we will be changing this. Okay. So yeah, this was all about this slide. Then I think yeah, we are covered with this. So yeah, if everything is clear, then we can start with today's topic. Yeah, so cool. Everyone, if anyone has any doubts or anything till now, take a minute to just sink everything in. Let me know if you have any doubts, anything is not clear, or you want me to basically explain anything again. Meanwhile, we will start with linear regression. Sorry, this was done, my bad. Okay, so let me quickly edit it. Meanwhile, maybe. So yeah, this is the topic of today. Okay. How do we handle multicollinearity in logistic regression? Rather, we have actually not till now studied logistic regression. So I think once we have studied logistic regression, then this question will make sense. Okay, it's exactly like we are still learning how to like about the alphabets and simple words. So if I ask you to just write an essay, it's kind of going like that. So I will politely ask you to just stay patient. We will do this, and then we can see that okay, how multicollinearity can be handled. Okay, if you just want a quick answer, then there are some regularization and techniques which we can take to handle cases of multilinearity. But yeah, does this also include complex model? Raghavendra, can you let me know which exactly complex models are you talking about? So we are here covering machine learning from the scratch. So we have kept it in such a way that if someone is, let's say, starting with the same, then he's also able to understand. Okay, and we are going, and I would say touching about on the maths also. Okay, so we are seeing that okay, how the maths got derived. So my aim overall with this thing is that let's say once you take the sessions, I'm pretty sure that you will have an overall idea. Okay, you will understand the intuition, how the derivations are done, and everything. So that let's say if tomorrow you are learning some variation of the let's say the algorithm which we have studied, or let's say learning the library, scikit-learn library and everything, you will be able to see that okay, hey, what this hyperparameter or what this parameter or whatever this let's say function is asking me, what exactly that value might be. Okay, so this is what overall we are seeing. So next question is, please cover up A/B testing in this series. Saran can do that. Actually, I intend to do a series on data science overall. Okay, like around let's say introduction to data science. Maybe we will do that next month or once the series is complete. Let's say a week after that. So in that, I intend to cover all the topics related to your basically A/B testing, or let's say collinearity and mean, median, mod, basically all the statistic things and all these things. In interview point of view, should we be aware of writing the linear regression from scratch? So yes, Charan, that actually can very well be asked. Okay, so normally if I give my example, if I ever take an interview, I'm very, I would say, fixated on understanding intuition. So let's say, for example, if someone asks, if someone I am interviewing and he say that he knows linear regression, I would be very much interested to understand that okay, why we are taking, why first of all, why gradient descent we are using. So my very first question is, can we solve the linear regression without gradient descent? I think 95% of people just fail that because they directly say no. Not really sure why they have what exactly they have studied and everything. Okay, so but they normally just say directly no. But I have shown you that we do get two equations and two variables when we solve the linear regression equation. Okay, then how, why we are not taking the absolute value and all this. If you basically pinpoint on these things which we have derived now, if you pinpoint in the interview and ask them a little bit deeper, most of the student, I would say 95% of the student fails them. What students generally do is they are very much fixated on learning most of the stuff but not going into depth. So people would actually, when I'm teaching about linear regression, they would be like, hey, what is L1 regularization, what is L2? So they would just try to point out the stuff which, let's say, you are not teaching, or which basically, let's say, is after what you have studied. After, basically, let's say we'll first cover linear regression, then we can see those regularization or anything. But in depth, very less students go. So in interview, that is very well tested. Okay, all the things which I have covered, they will actually be interview type of question. If you say linear regression, so your interview will be very much interested in understanding that, okay, why exactly are you doing what you're doing. Okay, so all these things are needed. Charan, I hope this is clear. Then one question, are we also doing some example on linear regression in Python later in this course? Anand, I covered a very simple example of linear regression, basically with which I am trying to understand you, the study hours and score example. We will actually, in the case study, we will try to include, let's say, we will apply the linear regression algorithm, even though, let's say, the accuracy can be anything, or even if it is bad, but we will try to use that. Okay, we can take actually one regression problem, classification problem. Again, we'll be keeping the case study little easy, okay, because I know few of the people are from college who are in second, third year, okay. So if I make it very complex, it might not be that easy to get to them. But we will try to apply that on let's say different variables. But the way I showed you, so that would also be available in resources, guys. So I hope if you will go into the iNeuron website, which I just showed in the starting, there was a resource tab here. So just download all the resources from there and let me know if you are getting the IPVNB file, basically the notebook file, Jupyter notebook, which I'm sharing and I'm also using in the class. Okay, I intend to basically make sure that whatever I'm using in the class, I'm providing you guys. Okay, so that is very important. So you can revise all of that. So in that, maybe Anand, we can cover that. Okay. Cool. So Charan and Anand will be good if I can get a quick confirmation that if everything is clear. Same from you, Raghavendra. If anything complex model more you would like us to cover, surely can do that. I am fine with, even let's say we are taking the complex of the model and going into the maths. I have intentionally kept few of the maths hidden, basically all those partial derivative and everything. Maybe I will cover that. Let's say if we take a little advanced ML course or something, so that it is reaching to the target audience. Okay, but yeah, any other complex model or anything which you want us to cover, maybe we can cover in this if it is feasible, or we can start with a new series. That should absolutely be fine. Okay, so yeah, everyone just get me a quick thumbs up or yes if everything is clear. So meanwhile, we will start with the logistic regression. So now, cool. Let us now move to the next slide. So yeah, this is just quick, I would say, introduction or quick overview about me. So I'm a graduate of NSIT. I have been doing coding for the last 10, 11 years. Like I had that in school also. Fortunately, was a little good in that. So went to competition in school level only when like I was learning C++. Then I started with machine learning, have a research experience, research paper in the field of ML. Technically, that was in deep learning. Okay, as well as basically I have done my professional experience also started as a machine learning engineer at Oyo Rooms. Then I went as an analyst and promoted to associate at Goldman Sachs. And then last I worked as a machine learning engineer in Mindtickle. Okay, so this is my overall professional experience. Have actually taught ML and have been doing this teaching and mentoring for the last 5+ years. Okay, so just to let you all know that, okay, who you will be spending your time with. So if anything from my experience will be helpful to you, or you think that, okay, any company, college, or anything I can help you with, please feel to ask doubt on that also. Okay, and yeah, you can also follow me on LinkedIn and just let me know if anything is not clear. So I have covered that a little bit in the first class. So yeah. Sorry to convey, I am from non-maths, can't be master in it. So Raghavendra, if you will see the classes, I have actually not made math a lot complex. Okay, so that is actually done intentionally. Okay, the thing is that even I understand that a lot of people are not from math background, or like it has been some 3-4 years since they learned a lot about derivative, integration, or these concepts, or let's say even the line slope form. So in every of my class, I have actually covered pinpoint on the maths, we have derived the formula. Like I would actually say that 80 to 90% and whatever is required in the interview, that is clear. Okay. So just the thing which we have left, I won't say we have left, it's just that, okay, whenever this kind of a, let's say derivation was coming, we have just pinpoint. I actually did that also in the last class. Okay. But if you are even from a non-math background, or if you have less, I would say, control over maths, you can still very well see and understand the session. I have never, and in anything, I have not given you any formula that, okay, I've given you the formula and I've been like, okay, revise it. Oh, sorry, learn it. So I have not done that. I have tried to explain you a lot on basically how we are coming up with that formula. Okay. So, okay, I think we can just quickly then start. Thomas is asking, sir, is the application of gradient descent similar among all the algorithms? So gradient descent, yeah, Thomas, it's an algorithm. There are few, I would say, types of gradient descent which might be used, but the overall idea remains the same, that yeah, we take up a value, then we basically try to reach the global minima there. Okay. So that overall intuition or overall aim is the same. Application wise, or let's say how it is used, can be different. So we saw a few types of types of gradient descent, right? So there might be some other complex, and basically more and more research is happening. So some variation keeps on coming. But overall, if you are able to understand the main vanilla gradient descent, I think that any variation should be very easy to get. Okay, so that is the stuff which you have to understand. Okay, so more or less, but yeah, in all the algorithms, we try to use gradient descent algorithm to reach to a global minimum, or basically try to optimize something. So algorithm in that way, basically that's the use, right? Algorithm will never change, right? But if let's say we have one algorithm, its application, its type might change, but yeah, in that way it will be fine. Anand is asking, whenever you have time to share a project experience with us, it would be great to hear from you. The real life scenario, it would be great learning. Sure, Anand will try to do that in any class which we get time, or let's say towards the end. In my experience, like, because I have done a lot of machine learning, deep learning, everything, and research work also, the experience in the industry is completely different, and I would say very enriching than what we are learning and everything. Okay, this surely helps. 80 to 90% this thing will help, but then the 10-15% of what you learn, that kind of is a very good experience for all your left 80-90%, which you can then refine. Okay, so I always try to basically also give you those examples. We will see that here also, but yeah, we'll surely share all that. Okay, cool. So I hope now everything is clear. Then we can actually, yeah, this is just a meme which I have made. So me, after explaining in interview why logistic regression is the best regression algorithm. Okay, so this is me when how my exam went, and believe me, I have had students whom I have asked that, okay, why logistic regression is the best regression algorithm, and like around 80% of them, they started explaining that. They started explaining linear regression, or they were like, yeah, logistic regression is actually used for regression. So this thing does happens, okay, because the naming is confusing, and after you will be learning 4 or 5 more algorithm, and if you don't revise or you understand the intuition, then you will surely get confused in that. Okay, so yeah, just to make you understand that, okay, why this is important, why we should understand this. Else your exam will be very good, your interview will be very good. You will be feeling like this only, but yeah, for sure you will have some, I would say, problems in when you begin. Okay, so cool. We will then start with our lecture quickly. Let me know quickly if you have any doubt. Okay, we can then start with this. Mohammed is asking how to proper paper the data for this algorithm. Mohammed, can you just explain your doubt a little bit? I didn't understood what you mean by paper the data exactly. Maybe we can take it after, let's say, we cover a few concepts. Okay, so the very first thing is, can linear regression be used for classification? Okay, so before basically beginning with this algorithm, I would just try to explain you guys that, okay, what data we will be working on. So consider there is a student, okay, or a group of students. More or less, you will be working on this data. Okay, so our study hours, this will be our X, okay, and your result. Okay, we will just take result here. We will not take score. So a very big change. It's a classification algorithm. We will have classes. If you have any doubt in classification versus regression, very highly recommend to watch the first video. We cover examples. We saw that, okay, what exactly is the difference? Binary classification, multiple classification. Okay, so we saw all that. Okay, so study hours, this will be your X and this will be your Y. Now, one more thing, what happened is that, yeah, I remember in one of the classes, students were facing issue in that thing. Okay, this is your dependent variable, and all the other variables are independent variables. Okay, so I think in the second or third class, I saw again for the doubts, and there were few students who were asking doubt on that thing, and I actually missed that, I think, in the derivation. So just please make sure that your Y is dependent on these algorithms, these variables. Okay, that's why it is a dependent variable, and this is an independent variable. Okay, I hope this point is clear and you remember this point. Okay, just give me a quick thumbs up or yes, because I don't want that we are we are basically moving forward and we forget the basics. It's always very good to remember the basics. Okay, making it the results of logistic regression interpretable, making it a valuable tool for explaining the relationship between independent and dependent variable. I think rather you are trying to explain me logistic regression. Thanks for that. We will actually be covering that. So I hope we can learn more on that. We will see that how exactly that happens also. Okay. Just a second. 1 second. I have to just see how to prepare the data for this algorithm. Mohammed, we will be, I have a Python notebook. You can see the data there. I will be preparing one data in front of you also. And normally you can see Titanic dataset or Iris dataset for any classification algorithm. Like these are the hello world of, I would say, classification problems. Okay. So just quickly see the Iris dataset. Okay. It's a classification level problem where you can see that, okay, what all is happening. So yeah, just how many dependent variables? So here we have just one dependent variable, as we can see, and one independent variable. Okay. For the overall understanding, we will be taking the binary classification case. We'll extend that to multiple then. Okay, again. So what I meant by binary classification is that just two classes we have. True, it is, let's say, passed and failed. We can also, and we generally basically write it as 1 and 0. So binary, everyone knows that 1 basically is on, 1 is pass, 0 fail. We are writing it like that. And let's say study hours is that if he studied 5 hours, he passed. If he studied 2 hours, he failed. Then let's say if he studied 3 hours, he studied 8 hours, 9 hours, 10 hours. Okay. So with all this thing, for 3 hours, let's say failed, and then let's say pass, pass, pass. Okay. Let us quickly also now draw the data. So this is our X. So I think Mohammed was asking about the data. Should be very quickly understandable on this thing now. So let's say we have 2, 3, 5, 8, 9, and 10. And this can be actually our data set. So let's say this is 0, this is Y, and this is 1. So in linear regression, what was happening is because you are dealing with scores, continuous value, basically each of our entry was a point in a space. Okay, but here that's not the case. It will actually be forming like this. So I'm just making 0 and let's say cross. So this will be our data. Okay, can you guys please tell me if this is clear? Because then we will move forward. Like I want to put that effort on the data, because if I use that directly, then it will be an issue. So just please tell me if this is clear. Can there be more than one dependent and independent variable? Yes, Pankaj, we can have the case. So along with, let's say, in the independent variables, I have study hours. Okay, then I can actually take a case where along with study hours, I am taking sleep hours, number of books studied. Okay, so all these things I can take. So we can have more than one independent variable as well. Okay, these are the independent variable. Similarly, we can have more than one dependent variable, but normally in those problems, we try to either club them or we write other algorithms. So let's say it can even have a score here. So we can basically write 2 algorithms, for one for regression, one for classification. But normally in professional, or let's say industry, as well as basically in our textbook examples, or let's say whatever we cover in the course, we try to make sure that we are taking one independent variable only. Okay, multiple you can take by combining, but yeah, that's the case normally. Okay, cool. So nice. Just who asked the question. Yeah, Pankaj, let me know if this is clear. Okay. Meanwhile, yeah, we can move forward if this thing is clear. Okay. So overall, this is how the data happened. So now, as we saw the linear regression, I will actually removing all this. If anyone has to write it, we can write. Linear regression is good for predicting continuous value. Okay, stock price, score in our data set, number of, let's say, runs a particular cricketer will score. So all this is what our linear regression does. So now the next thing is which you want to understand, which you also saw on this data. Then what if our y has classes now? Okay, so what if our y has classes now? So classes can be pass or fail. You can spam or not spam. So basically you can let an email tell you that if it is a spam or a not spam. Okay, then the next can be, there are a lot of algorithms. If you will see that it is cat dog type, that okay, more or less it is entry level into when we do go into deep learning and CNN. But yeah, telling by the image that if it is a cat or dog, kind of very important data, or let's say very common data, MNIST. So MNIST name might be a little bit heavy, but what it is, it just that I have images of like this, let's say where 0 and 1 or things like this is written, and you have to tell what digit it is. Okay, so it is also a classification problem. It has 10 classes. So you have images from 0 to 9, hence 10 digits, and you have to tell that okay, what exactly is the I would say what exactly is the digit class. Okay, so if, for example, this is 0, this is 1, and this is 9. Okay, I hope this thing is clear. Okay, so as I said, first we will see for our binary, then we will see that okay, how we can handle multiple also. Okay, Ullas is saying Flipkart review positive or negative. Yes, Ullas, it's a binary classification problem. Let's say if we take so this type of problem is normally known as sentiment analysis. That what is a sentiment of a particular class, like in terms of, I would say, industry or let's say professionally, this kind of thing is known as sentiment analysis. Okay, so yeah, first as I said, we will be dealing with the binary and then we will move to our multiple. So let me move this quickly again. Just keep on giving me yes thumbs up if everything is clear, because that even helps me to keep all energetic, and if any doubts just ask them, I will revisit them. So now let us see the difference of exactly how things will happen, so that it is clear and you never basically get confused in linear regression and logistic regression. Okay, so linear regression we have seen, like I have made this I think in the last 3-4 days around more than 100 times, but this is what we have for linear regression, and I just showed you guys. Okay, let us take 0. That this is normally the case with logistic regression, because we have classes now. We have 0 to 1 classes now. Okay, so now in linear regression we saw that our line is kind of going like this. Okay, we try to find the best fit line, okay, which we try to come up with. But on the other hand, in logistic regression, ideally I think this should be the kind of a line which we should be looking for, right? So let's say what exactly is happening here is, like we can ask logistic regression only, or let's say it can even create a line like this. Okay, based on slope values or let's say constant, whichever it tries, it can actually try to come up with this value. So now what we can do is, now up to us, it will still give us continuous range. Okay, so it won't give us 0 or 1, it will give us let's say 0.58. Okay, or let's say for that matter it can even give us 0.01. What we can do is we can have a cutoff at 0.5. So this actually, okay, let me draw it. Actually we can take it like this only. So we have this cutoff, okay, at 0.5. So any value which is greater than this 0.5 we are labeling as 1, and any value which is basically less than this 0.5 we are basically taking as 0. Okay, so for example, if tomorrow I have this first of all, let me remove this line once. Okay, everything got removed, but no worries. So let's say this is my 0.5 value. Okay, so tomorrow if let's say I have this data set, this x dash, okay, or x dash, this is basically your new test value. For example, this can be if it studied let's say 6.5 hours. Okay, then we will just see on this line and see that okay, this is coming let's say somewhere around 0.7 with this thing, and we can label it as 1. Okay, so he will pass. Okay, so basically 0.5 is actually the cutoff value. Okay, or we are taking that as a threshold around which we will make our decisions. Okay, so the thing overall, we can just now get rid of this because this is our understanding. So it is pretty easy to understand that okay, if y prediction is greater than 0.5, then it is 1, implies 1, else 0. Okay, so yeah, we can actually use linear regression with the same. I hope this thing is clear. Okay, so our best fit line will remain as it is. We can use linear regression and everything is fine. So yeah, that I think should work well on logistic regression as well, right? But of course, now there are two problems with that. Okay, two big problems. And okay, of course, this can also be asked in an interview. Everyone, if an interview can ask that, hey, can we use linear regression for classification? The answer is a very bold yes. Okay, like if someone says no, that's an issue. Answer is a yes. We can use linear regression for classification, but along with that, you should be able to explain that. Okay, why exactly is this happening? Why exactly? What exactly are the problems with that, which we will just see now. Okay. So now the two problems which we have is, I would actually like to try and just remove all this. And now if you will see this graph again, so I have to draw a lot of graphs, but yeah, if let's say this is 0, 0, 0, and this is x, 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 x. Okay, so these are pass and let's say 1, and this is 0. These are the study hours, and this is the result. Okay, y-axis, x-axis, just seeing the binary thing right now. So let's say our line is made something like this. Okay, this is our best fit line as of now. Okay, so I hope everything is clear till now. Now, what will happen if let's say I add these data set in my training? Okay, so let's say these can be 10, 12 hours, 15 hours if we take cumulative hours. Okay, so these are the values which we have added now. Okay, of course, now to I would say fit in these values, our best fit line will change. Okay, I hope this is clear that our best fit line overall will change. Okay, it can actually become something like, let's say it is becoming like this. Okay, so our best fit line will try to accommodate these values also because it will train on this. So our slope and basically intercept will change on that. And if let's say this is the 0.5 threshold value which we have, okay, if we go here, so earlier this was my x basically threshold value, this. Okay, let us draw an arrow here. So this, you see, it has moved. Okay, so now if you see, if let's say my value is somewhere around here, okay, let's say somewhere around here, then if I try to find out, it is now basically giving 0 for all of that. Okay, earlier it was giving this as pass. Okay, Ria is asking, could you repeat once? Okay, so no worries. So Ria, what I'm actually just telling is that let me move this, no worries. So Ria, yeah, removing all this, just pay close attention this time. What I'm saying is, this is my result. These are my study hours. Okay, y, x. Let's say this is 1. If we passed or failed, this is 0. This is 0.5. Okay. Now let us make few points. So this, let's say, is 2, 3, 4 hours when it failed. Then let's say this is 6, 7, 8 hours when he passed. Okay, I hope everything is clear till now. Now, if I ask my linear regression, so I'm just talking about linear regression right now. The basically title of slide is also, can linear regression be used for classification? My best fit line can come something like this. Okay, so completely valid best fit line, we can just cut off this value on, we can just try to cut off this value on 0.5 as well. Okay, this is our cutoff value. So if we see, basically this is our x dash. Okay, so now if let's say this is 4.5 hours, let's say, so now anyone who studies greater than 4.5 hours will get pass based on our model, and less than 4.5 hours will be failing. Okay, so I hope everything is clear till now. Just let me know, drop a yes or thumbs up to make sure that everything is clear till now, because it is very important. Cool. So now what I'm doing is, I am adding few other points here, let's say. Okay, so in my training data only, I am adding, let's say, 12, 15, 16 hours. Okay, now what will happen is, of course, to accommodate this point, my best fit line can change. Okay, so let's say somewhere like this it is coming. So this is my new best fit line. Okay, let me actually draw this by green only, which will be better. Okay, 1 second. Okay, so just let's say, yeah, this is my new best fit line. Okay, this is second. this is 1. Based on the best fit line, my threshold value will also change. So this can be x double dash, this can maybe let's say 7 hours. So now what we are seeing is that earlier my value was 4.5 hours, now it is 7 hours. Okay, so now it is kind of like everyone who studied less than 7 hours, he will fail. Okay, but of course, like few data sets are, we can see that okay, they are coming out of this. Now our data set kind of has become imbalanced. Our lines have basically, I would say, moved in a direction which we didn't want it. Okay, and this will have an effect that let's say if any new value which you are predicting, they will basically be on this line. And now if you think very ideally, okay, adding these points ideally should not have an effect on these, right? Well, let's say if we have the around the threshold value, if we have the points, then someone can tomorrow study around let's say 18-20 hours. Around here this value will be, let me show the red for this. So around here this value would be, okay, but he will still basically let's say he is also passing and 5-6 hours is also passing, but based on those values we are changing our full line. Okay, so I hope this thing is clear. So our 0.5 cutoff is getting changing, and basically adding these outliers, okay, or extreme values, I would say, they are basically making our whole line to shift. Okay, and our whole boundary is getting changed. Okay, so this is the first problem with linear regression thing, that if we have outliers, then basically our line kind of, I would say, fails and it gives us a very bad fit line. Okay, now you can see that okay, threshold value is changing. Tomorrow if you have other values, then this kind of stuff will also be there. Okay, so I hope this first problem is clear with our, let's say, first problem is clear with the using linear regression for classification. Okay, this is the first problem which you might also have to explain in an interview. The way I have explained you, if you explain it like this, interviewer will surely be very much impressed with you. Okay, people know that okay, the outlier is the issue, but if you ask them how to explain, that is where most of them, even 90% of them, fumbles. Okay, they will be like, yeah, we can have outliers and that will cause the issue in the best fit line. If I then ask them that okay, explain me how it will cause an issue, then most of them are just drawing random lines, honestly. Okay, so just please remember how we have done this. This is very important. Okay, so just removing all this now, let us make this again. Again, if we have a line like this, let's say points like this. So this is the second problem now. First was outlier. Second problem is, let's say we can have a best fit line, which is something like, say this. Okay, so this is our best fit line based on this data. Now, let's say if I have a value where someone studies, let's say this is around 11 hours. Okay, now if we see the value for this 11 hours, this is coming greater than 1. Okay, so let's say this value is something around 2. Similarly, the same issue, if let's say we see someone who has studied 0.5 hours, we are seeing that it is negative. Okay, this thing is negative. Okay, now, of course, I think you are able to understand that few values are actually less than 0. We can basically make them to 0, but it doesn't make sense, right? And few are also greater than 1. Okay, tomorrow we can even get a value, let's say plus 200. It is a lot based on data. So I don't think this makes a lot of sense that okay, you are getting this kind of values. Okay, plus 200, negative 50. Then you're trying to basically fit them into 0, 1. Okay, this kind of output is not kind of expected, right? Like how will you explain that okay, plus 200 is the value? If 0.93 was there, maybe you can try to explain this with the probability and say that okay, this is the percentage and something. But yeah, this is what is happening here. Okay, so they are not the right values for classification. I would say these kind of value, minus 50, things like this, these are not right values for classification. Okay, so yeah, these are the two problems. I will just quickly repeat and write them down. Yes, they are problems. So first is outlier or extreme value. Second is output range. If anyone wants to write them down, write it down, just draw the examples, but these are the two values. Please just give me a clear or thumbs up in comments, so I'm assured that okay, everything is clear. Okay, this thing is very much required. As of now, we have just covered linear regression, how basically this linear regression cannot be used in classification problem. basically why using this is a problem. Like it can be used, okay, but why using this is a problem, and it will be a very bad model. Okay, so if everything is clear, we will go on to the next slide. Can I just get quick thumbs up and clear messages? So I am aware that okay, you don't have any doubts in this. So now let us kind of so like taking a little detour now, we will just so whatever I've told you right now, just remember that. Okay, we will now just quickly see one generic concept around classification problem that is very helpful. That is decision boundary. Okay, so now in a similar way, let's say we have this thing, and let's say I have these data set in linear regression. So now our best fit decision boundary may be something like this. This is our best fit decision boundary. So everything on the left of this is 0, everything on the right of this is 1. Okay. So normally in classification problem, it is very easy to understand, and I would say intuit as well as to understand if we have grasp, basically if we have the graphs in mind and if we understand what decision boundary is. Okay. So our decision boundary in a similar way can also be something like this. So I will be drawing the classes with some different symbols. So let's say this is one class which you have. Let's say a circle is the other class which you have. So now the decision boundary can be this. Okay, like we have everything towards this as 0 and everything around this as star. So yeah, what we try to do with any algorithm is we try to normally come up with a decision boundary in graph. So we can tell that, hey, around before, like let's say anything below this value is something, greater than this value is something. Okay, so one more thing to remember here is that these decision boundaries, they can also be non-linear. Okay, so we can very well end up with the data which kind of, let's say, is something like this. So we saw stars and we have 0. Okay, we kind of have, let's say, some data like this. Okay, data point like this. Here our decision boundary can be like this. Okay, so it is a non-linear decision boundary. It might not be possible with using simple logistic regression normally. Okay, even you can say that it might be like it's a good decision boundary, but maybe we are overfitting on the data. We will see all these things, but yeah, the thing to understand is that we can have non-linear decision boundaries. Okay, it might not be possible with this, I would say, using the normal logistic regression, but yeah, we have the cases or few algorithms which can even provide us with decision boundary which are non-even. So everything outside of this is 0 and inside of this is star. Okay, so this thing is very clear to, very important to understand. So now, yeah, we will move on to something called activation function. You don't have to think more on the name. I always tell that yeah, name is just the thing which we don't have to take a lot of value on. Okay. So now we will come back on our analysis which we have done. Okay. So we saw the issue which we have were because of two things. Okay. This was something of our line. Okay. Let me remove this thing. Actually, let me remove this line and draw this with red so it is more clear to you. So let's say this is our line. Okay. We saw two things. Okay, like the first one was that if let's say when we are training the line, if we are getting this value as very big due to basically due to availability of outliers, then the line was getting shifted, and similarly we were getting values which were greater than 1 and less than 0. So the first problem was outlier, and the second one was basically output values. Output, let us write it like this, values. Okay. So now, how many of you think that what I'm now doing? Just think of this very intuitively, why I'm doing this and what I'm doing exactly. How many of you think that it will basically solve our problem? So what I'm doing is I'm trying to squash these boundaries. Okay. So I'm kind of cutting this, and let's say this is 1. Let's say it is here. So we are not going above. We are just squashing these values here. Okay. And this overall, actually, let me just use the black line for this. So it is not, sorry for a lot of drawing, but I hope this is actually the line which we are talking about. Let me just, I don't think I have highlighter here. No. So no worries. Let me just, think of this is the full bolded thing is what I am trying to basically do here. Okay, I am saying that this we have to do this. cutting of line or squashing of line, okay, around 1 and 0. So while training also, if let's say I'm getting values which are greater than 1, then I will just cut that, take this as 1. And okay, this will solve both the issues in a way. That output value, if let's say it is coming at greater than 200, greater than 1, let's say 200, then we will just squash it and we will just anyway see this as 1. Okay. Now, how many of you are able to understand this? First thing is that Vineet is right, this may be sigmoid function, but the thing to understand, Vineet, here is the intuition and why we are doing what we are doing. Okay. Yet it is sigmoid activation function, which you will see. But right now, you can, all of you others can forget this name and just tell me if this intuitively, what I'm trying to explain, this makes sense or not. Okay, that we are squashing our boundaries. Okay, this is what we are doing. So now another observation which you will now see is that still my line equation is this only, y is equals to mx plus c. Okay, don't see this as a multiplication, I've just written it diagonally. So still my equation of line is y is equals to mx plus c. Is this thing clear? Yes, yeah, there are outliers, but what we have done instead is that instead of training our line in a way where let's say our outliers would have given a value of plus 200, okay, and changed the slope and constant, now we have taken this as 1 only. Okay, so we have changed our line. We have basically make some changes in our line. So the equation of this part of line overall, this still stays y is equals to mx plus c. Is this thing clear or not? There are still outliers, but we have changed our value, but the line equation remains the same. It is very important to understand that why line equation remains the same. Cool. Thanks, yeah. So now, okay, let me just remove it here. So just remember this is squashing and it helps. So now one thing is there, our y, okay, no, just give me a second. So now my y, if you will see, okay, it basically has changed. Okay, it is still some function of, okay, just a second, why it is showing different color. Just give me a minute, guys. Yeah. Cool. So earlier my y is equals to mx plus c. Okay, now we can see that it is not that value, like it is not mx plus c, but this overall, this line is some function of, so let me write it like this, some function of mx plus c. So it is basically some function of our line. Okay, like we have of course modified a line, right? We have changed it in this way. Okay, we have made those changes. And now let me take this as, let's say, z. Okay, so this is basically some function of z. Okay, I think it won't be clear. Sorry for my bad. Yeah, I hope this is real, like let's say available on the right end. Yeah. So by this question, we are just not going to consider the outlines in the model training. Is that correct? No, Anand, that is not correct. We are still considering the, I would say, outliers in our training, but instead of taking those values at what mx plus c would have given us, we have changed our line in such a way that we would be taking that value as 1 only. So earlier what was happening is, let's say we would have, so just quickly understand it here. Let's say we would have made this line like this. Now because of our outliers, let's say this, or let's say wherever our outliers are, this value would actually be changing our m and l, m and c, slope and intercept, and this line would basically getting changed like this. Okay. So now, but what I have done is, any outlier which we have, we are not taking the absolute value which we will get from mx plus c. We have squashed it to 1. Okay, so anything up greater than 1, we are just giving that equal weightage. So it is not like, if let's say our outlier is very far away, you are taking that value, let's say plus 200, plus 500. No, you have now squashed this in a way that they have a same weightage or same effect on your line, or let's say on your m and c. Okay, this is what we have done. So I hope this is understood and clear that what exactly we have done here, and why now this is not exactly the line, like this line equation still remains the same. That is the intuition, but on the same end, we have made some changes into this. Okay, so we want a function like this, kind of like this. Okay, so now let me just quickly get rid of this. We do have a very good function which kind of is like the one which we want to use. Okay, so if we make it here like this, okay, this is normal graph. Okay, so the activation function which we have written on this, okay, this is basically something like this, right? Coming something like this. So this is our 0.5. This is basically our 0.5, and this is 0. So it is going a lot quickly towards, and this is 1. This is our activation function. So you will see that it is more or less in a way how we wanted it to be. So that phi so will become inline. Yes, Anand, that understanding is correct. So yeah, now the equation of this will basically become, now the equation of this function is 1 upon 1 plus e ki power minus z. Okay, here our z is mx plus c only. Okay, so now just to make you understand quickly again, in linear regression we were using this to get our value. Okay, in linear regression we were using this, but now we will be using this value where our z is equals to mx plus c to get our y predicted. Okay, so to get what is the value of my y predicted, we will be using this value. And this value, you will see that it is constrained by 0 and 1. Like it is not going outside that. Okay, so whenever we will be training our model also, we will be taking values based on this and then train our model. Okay, this thing is very important to understand. We are still keeping the constant, the variable m and c as same. Those variables are still m and c. Okay, but we have changed the equation. Okay, so this is the, I would say, overall intuition which I want you guys to understand very quickly. Okay, just let me know if there are any doubts or anything, then only I will move forward. Because if we don't understand this, then it would be a problem. Okay, I can also show you guys one thing very quickly, that how this thing is. So let's say this is my function, right, which I have written you the equation for. This is basically my function, right? So if let me actually try if we can use internet for this sigmoid function graph. So we can, let's say, see this. Has anyone drawn it? Okay, where is the Google Graphs? Like the library used to come. Graph diagram. Okay, I'm not sure why I'm not able to get that graph thing. So let me try this graph of sigmoid. Graph of sigmoid function. Okay, it is still giving like this, but anyway, this is my graph, right? This is actually the graph which I have drawn also. So let me anyway explain that with other things. So yeah. Okay, sorry for this. We have to full screen it to make sense now. Yeah. So when z is your infinity, let's say when z tends to infinity. First, can you please, anyone can tell me like if we have any issues or anything with this, then only I will move forward to explain what I'm going next. Okay, it will be very helpful to basically clear this out once that okay, this is if this is clear or not. Okay. Just can I get a quick thumbs up or yes for this thing that okay, this is clear. That would help me a lot in understanding. I'm just seeing the comments because then only I will move forward. Okay. Okay, cool. So just to now intuitively understand more things. Okay, 1 second. Yeah. So when a z tends to infinity, okay. So let's say when so z is what? Y is equals to mx plus c. We have seen that this is mx plus c. Now let's say my mx plus c value is coming out to be 500, 600, or let's say anything. So you will see one more thing in this function. It is very quickly going towards 1. Okay, like it is running towards 1 and 0. So it is on 0.5, it is 0. Okay, on x is equals to 0, this is 0.5. But as long as you try to basically make the values, or let's say change the values, it is going very quickly towards your 0 and 1. Okay, so now this value of z, how you take that formula 1 by 1 plus e ki power minus z. Akshata, yeah. So Akshata, actually what we saw that we actually made this kind of a line. And this formula is actually kind of based on research that yeah, we actually kind of form this kind of a line. And we then, based on different formulas which can fill, we saw that okay, sigmoid function is one of the function which is having a similar graph like this. Okay, sigmoid is a function where the graph is very similar to the way we want, where we have the output constraint in 0 and 1, okay, and which is moving very quickly towards these things. Okay, so this formula we have taken because sigmoid function is a function which we have chosen here. Okay, we have chosen this function and the equation for the sigmoid function is the one which I have given. Okay, this normally how it happens, because I have research experience, I can tell you that what we see is, let's say if we make some hypothesis that hey, I want this kind of a function. Okay, now I have either I can take some conditions that okay, if it is greater than 1, then take it like this, or we try to see that okay, which function can help us. Okay, now researchers in that way then see multiple functions that okay, what will be able to fit. There can be some function, let's say, which is around like something like, so normally this is like s, okay, some function going like this or something, and then we basically see that hey, this function seems to do the trick. It is falling very close to the way I want it. Okay, and that is how we have finalized sigmoid function. And sigmoid function is having the value of the formula of e is equals to mx 1 by 1 plus e to the power minus z. That is how we have selected this function. Thomas, so does the sigmoid function scales the output from 0 to 1? It doesn't scale the output from 0 to 1. It basically have a cutoff there. So let's say if anything, so I was just showing you guys this only. If let's say my value of y, like my, let's say that my linear regression line which we saw, it is giving some value which is tends to infinity, let's say plus 200, plus 500. Those are of course very big value. Then your this function will tend to 1. Okay. If someone wants me to solve this, it can be 1 upon 1 plus 1 by e to the power infinity. Okay, this will basically, not sure how good we are with maths, so this will basically tend to 1 here. And similarly, if I take z as minus infinity, where let's say it is giving us as minus 5, minus 500, something like this. Okay, then our e to the power minus z will basically be e to the power minus infinity. Okay, and it will basically, our overall function will tend to 0. Okay, so this is the whole thing which we are taking. So let me just quickly remove this. Let me just draw this again for all of your understanding. We had a function like this. Sorry for the double line. We had a function like this. We squashed it here. Okay, we saw that okay, this line is still mx plus c. This squashing kind of helps. We saw that okay, which function we can actually use here, which function is basically the similar way, I would say in a similar way, which function is helpful here. Okay, after this basically squashing, so we tried to now come up with and saw that okay, there is a sigmoid function which we can use. So this is 1 minus e to the power minus z. I can also write this as 1 plus e to the power minus mx plus c. Okay, so this is my line equation I'm still using. I still have two variables, m and c. Or x can be your study hours, but m and c are my two variables. Okay, it is constrained between 0. It like tends to 0. So ideally this negative, like this thing might not be right. Okay, and 1 by 1 plus e ki power minus mx plus c. This tends to 1. I would like, let me write it like this. Okay, so for infinity basically is the values are equal. This we find that okay, for logistic regression we normally have two classes, so 0, 1. Let's say in binary logistic regression we have just two classes. Okay, so we are okay getting that okay, this will be giving us the value from 0 to 1 only. Just to draw the graph of this function, it is something like this, where it has a cutoff value and it then tends to infinity. Like not it tends to infinity and 0. Okay, like very quickly it goes here. Okay, very quickly it basically tries to penalize the error. So let's say at 0.5 it is somewhere around y is equals to 0.5 at x equal to 0, but even if you make it 0.8, it will go very quickly towards your 1. Okay, so that is what is happening here. So now I hope this thing is clear. So this is helping us in doing the squashing. One thing to understand here is rather two things. Just let me quickly clear this. Your equation y is equals to mx plus c was there in linear regression. This was for linear regression. We are using this still, but now our prediction function, this was our prediction function in linear regression. It has changed to this instead. So now I will actually show you this with the help of code and example also. But now if you have value of m and c, you will be using this function to get your value. That okay, what is my class value? You won't be using this function. This thing is very important to understand. Okay, the first thing is this. Second is that so if we see our function, sigmoid function, like graph of this function, I told you guys that this is 0.5 and it is coming something like this. Okay, so basically what we will say is that, let's say normally what we have the threshold value as y equal to 0.5, right? We have this as a threshold value. Any doubt here why this was a threshold value we took? Now that if my predicted value is greater than 0.5, then I will basically say that, hey, this thing overall is, I would basically write it as 1. Okay, so I was taking 1 as my class. So now if we write it like this here, e to the power minus z greater than 0.5. So, or let's say mx plus c rather, z I can write mx plus c. So, if we do some quick maths, actually let me just quickly show you. So, we make lines by two ways, okay? This line is x is equals to 4. This line is x equals to 4. Anyone has any doubt in this? Why this line is x equals to 4? Just quickly ask me, let me clear this actually what I'm trying to explain here. 4 and this I'm making the line and I'm saying this line is x equals to 4. Any doubts here? Why this line is x equals to 4? Every value on this line will have x value of 4 and y will change. Okay, this is what is happening here. Now, if I say x greater than 4, then it is not a line. Okay, it is not a line. This rather is this area. So we had a problem, we had done a problem in high school where we used to get problems like this. Let's say x greater than 4, y less than 3, and let's say x, y less greater than 1. So what is the area which is constrained, like area which is we are getting, okay? So just want to show that this thing, this equation gives you the area overall, okay? In a similar way, when I wrote that, okay, 1 by 1 plus e ki power minus mx plus c greater than 0.5. So this is my y prediction. This is what I will get by y prediction. So here I will be able to get my mx plus c and I will be able to get my decision boundary. Okay, this is very important to understand. Once I solve this equation, I will get something, let's say mx plus c is, let's say, greater than something, and this will be giving me my decision boundary. Okay, so the decision boundary concept which we discussed, it is actually applicable here, that we can actually find the decision boundary also. If we have this m and c with us, then we can actually come for this x. Let's say we have calculated that m and c. Then using this, we can find, okay, that what exactly is the value above for x above which my let's say result will be pass or fail. Okay, so this thing is again very important to understand. So I hope this overall thing that, okay, which we explained here, that why we are taking this as my prediction. Okay, y hat 1 plus e ki power minus mx plus c. Why I'm taking this as my predicted value. So let's say if I ask you now, what is the result if student studies 7.5 hours? Okay, you will train your model first. You will get the values of m and c. Okay, and you will plug the value of 7.5 hours here. This will give you a value strictly between 0 to 1. If it is less than 0.5, you will tell that, hey, student will fail. If it is greater than 0.5, then you will say that, hey, student will pass. Okay, so I hope this all thing is clear to us. If like any doubts are there, let me know, else we will move to the next slide. Okay, thanks Sanju. Anyone can I just get a quick thumbs up, or basically yes if everything is clear and we can move to the next slide. Okay, so the next, actually, yeah, thanks Akshita. So I see that, okay, next slide is error function. Just to quickly remind, what error function we were using in linear regression was, it was a function of m and c. We have 1 by 2 n summation I is equals to 1 to n. N is my number of data points. Okay, then y actual, because it was a score, minus y predicted, which we used to get via mx plus c and the whole square. I told you that we do this 2 by n to basically take the mean. Okay, so I hope everyone remember this formula. This is the cost function for cost or error function for linear regression. We discussed this a lot in the last class yesterday. Now here, if you will see, what have happened is that my actual is now not a score. Okay, it is the label 0 and 1. Similarly, my predicted y predicted, it is something like this, minus mx plus c. Okay, so when we were actually plotting, we can actually for the understanding take c is equals to 0 again, should be fine. Okay, so when we were plotting this function, the linear regression function, this one, okay, this function was actually giving us a convex kind of a function. Now what I meant by convex, you can actually think of that it had a global minima. Okay, so this function, when you were derivating it and you were seeing it, basically this was kind of giving you global minima. Okay, if we do the same thing when we change the values with this, and let's say for this function, if we try to see what we are getting, the function would be something like this. If someone wants it, it can also basically, he can try to print like put in those values. Let's say just take this, remove this seed, will just take a lot of time. So that's why I'm just skipping this. But the final output is that we will get a function like this overall. Okay, so let's say it will have global multiple. So if you will see, this is your local minima and this is your global minima. Now let's say if I start my gradient descent algorithm from here, okay, it will actually, it can get fixed, or let's say it will get stuck here. Okay, we will see that yeah, this is one of the minima. Okay, it will see if you will actually get stuck, your slope is kind of your this del j by del m is kind of coming to be 0. Okay, so this implies your m new, which we wrote as m old minus del j by del m. This kind of is becoming 0, and we want to actually not stop at local minima. This, if you can see it, this is not our global minima where the error is minimum. Okay, but we can get stuck here because this will kind of become close to 0. This del j by del m will tend to 0. Okay, and then our m old will equal to m new. Okay, so I hope this thing is clear here. Okay, normally to put it a little bit more formally, what we can say is that we have one kind of a function known as convex function. Okay, which kind of is something like this, where we have a local global minima, and then we also have non-convex function. I'm just trying to just touch upon it a little bit. We can even cover it in more details, like what are different these function, but that would be based on maths. You can maybe read this on the internet also. But yeah, these have a lot of local minima and one global minima is here. But yeah, we can get stuck in the local minima. Okay, so this is non-convex versus convex function. When we are making j versus m for linear regression, we were getting this kind of a function. But if we use the same error function, okay, why we are reading all this is, so see, we have the equation, we have the y prediction thing. Okay, we got that. Okay, how I can get the latest value of y, the value of y prediction for a new data point. Okay, now I also want to optimize it on m and c. We saw that these variables are same. We still are anyway optimizing for m and c only, right? The way we were doing in linear regression. But for optimizing, we need a error or cost function as we did in linear regression. Okay, so now because we need this cost function in linear regression, what it can actually give us is that when I try to plot that function with respect to this, we see that this is a non-convex function. We have a lot of local minima, okay, which we can get stuck in, and we won't be able to get the, I would say, we won't be able to get the optimized value of m and c. Okay, and we want the optimized value. So this is why we are doing all this and trying to understand that why we cannot use the same function for basically this logistic regression. Why linear regression function is not the same for logistic regression. Is everything clear here? Can someone please tell me if they have any doubts or anything, or if everything is clear here? A quick thumbs up and clear will be helpful so that we can move forward with this. Okay, just see the what I have written and everything, and just let me know if this is clear or not. Cool. Okay. So now we have kind of actually incorporated that we cannot use the same linear function. Okay, sorry, error function, we cannot use the same one. So we need to come up with a new error function. Okay, and ideally we would want that error function to be a convex function so that it has a single global minima. Okay, so we want some function, something like this, that some single global minima is there on which we can optimize our m and c value. Okay, So the function which we use for this is known as log loss function. Okay, log loss function it is known as. Okay, which, so this is your error function only. Now what this function mean is that we will take minus log of y predicted, okay, when my y is equals to 1. Okay, first let us understand this only. Okay, that let's say this I have written. Okay, so now if you will see what is the graph for this. Okay, normally what exactly is the graph when I make for this particular y log x is, it goes something like this. Okay, actually let me show you the graph of minus log x. Just let us quickly check that also, so that you guys are still getting the intuition. Graph of minus log x. Okay, I think it is not taking, yeah, see. Okay, I'm not sure if, okay, just give me a minute. How can I open this in the new, okay, just a second. So I hope this part is visible to all of you. This is the graph of minus, okay, just a second, I will have to also, yeah, this is the graph of minus log x, the current function which I have taken, right, which I told you guys to take. This is the kind of a graph which we are getting. Okay, so we get one half of this thing. Okay, just I'm showing you this guy, this to make sure now I'm not giving you something and you are remembering it. No, this is the reason which we are taking this is that we are kind of getting by using the log loss function. Okay, we did a lot of research and then tried to come up with a lot of function, and we saw that for a case where we are doing classification problem, let's say where our y is equals to in the range of 0 to 1, 1 plus 1 plus 1 by 1 plus e to the power minus z, which we saw. Okay, basically our x here, what x is? X is this only, minus mx plus c. Okay, so for this kind of a function we made this kind of a graph, and we this I told that we are taking just for x is equals to 1, or sorry, y is equals to 1, y actual here basically. So now if I clear this, let me write this again. I have 2 pens right today, so I'm getting a little confused, but anyway, y, sorry, not y, log loss function we were writing, or we can write error function for, I'm writing function like this, so f with a small n and LOR, logistic regression. Okay, so which we saw is that it is minus log y predicted when my y actual is equals to 1, and similarly, so I hope this thing is overall now clear. Similarly, it is minus log 1 minus y hat when my y actual is equals to 0. So what I'm saying is, hey, let's say the student failed, okay, and let's say he studied for, so my y hat will become 1 by 1 plus e की power minus mx plus c. Let's say he studied for 3 hours, okay, and he failed. Take this function and calculate what was the loss there. Okay, and in a similar way, now the graph for this we saw already. So let me just write, basically draw it like this. So the graph for this we saw is something like this. On the other hand, the graph for this function, right, it is actually it does come out something like this. Okay, so now when these functions are basically, so I have written this thing in a way, like let me remove this thing. Now I will just write one quick thing. Okay, so I hope you are able to understand, basically get that as well. Okay, so this overall, when we use this will give us a function like a convex function, and then we can get a global minima for that using our gradient descent algorithm. So to keep this in line with linear regression, okay, to keep the overall intuition and everything with linear regression same, what we have done is we have taken and finalized this function, log loss function, and this is a convex function. Okay, so in the convex function, if we use gradient descent algorithm, it will be able to get us to a global minima. Okay, so yeah, we can actually combine this thing also. Let me know if this makes sense. If not, I will try to quickly explain you this also. Minus y log y hat, okay, then minus 1 minus y log 1 minus y hat. Okay. So this is the overall function. Now, I hope you are able to understand it, but let me just help you a little bit. So we took, let's say our y actual is 1. First take this 1. If I change 1 here and this becomes 1, you will see that 1 minus 1 is 0. So this part, this whole part will basically get removed. Okay. This whole part will basically get removed. On the other hand, if I take y is equals to 0, now this is 0. Okay. And this 0, it will become 1. Okay, so this whole part will now get removed and only this will remain. So we have just combined this thing and written it in a way which is clear. So just let me actually clear all this and write this again. Error function is equals to minus y actual log of y predicted minus 1 minus y actual, and your y actual can be just 0 and 1. We are doing the classification problem, binary classification. It can be either 0 or it can be 1. Okay. Log of 1 minus y predicted. Okay. So just quickly have a look on this. My y hat or y prediction here is 1 by 1 plus e to the power minus mx. We can write minus c, like I've just taken this, remove this bracket. We can even, if we are ignoring c, that it is e to the power minus mx. We know that this will be constrained from 0 to 1 only. So my y hat will basically give me a value that, okay, which class it belongs to. Okay. So just quickly, if anyone can tell me, so what we will now do, our steps will remain the same. We have an error function. We have m to calculate. Okay, we will, if we basically make this error function with respect to m, so j to m, we will get a graph like this only. We will start with a random value of m. We will take any value of m, and the whole thing now remains the same. Intuition, we will basically, if you will see that it will try to move here only. So the same thing we will do, m old minus del j by del m. So this is my j, this error function is my j, and this will be equal to m new. Okay, we can add a very good hyperparameter here, which is alpha. This can be used. Okay, so all the steps which we have discussed in linear regression, all of them can be actually used here. Okay, just quickly have a look. Okay, I know it's a little bit like kind of flying, but let me draw, like, okay, let me just square the formula so that it is quick, easy to for you to get to. Okay, so let me know if this thing is clear. Okay, let me know that, okay, you are able to understand that, okay, how we come to this thing and why now we can use this gradient descent algorithm in the similar way that we used for linear regression. Okay, that is very important. So just quickly have a look, give me a quick thumbs up, and yes, if everything is clear. Of course, basically based all of this on intuition. Try to make it in a way that you don't have to remember anything, and believe me, like nobody like teaches you in this depth. If you are able to tell your interviewer these algorithms in this depth, for sure he's not going to reject you, for sure. Okay, and believe me, this is very, I would say, enhanced and very basically everything is covered in this. Okay, it's not like you are missing out on anything. I just kept it in a way that it is slowly, and it is basically we are forming a story. But yeah, more or less, this is what everyone is kind of asking you. Okay, so I've tried to basically have all these questions which someone can ask. That, okay, why this function was finalized, why we cannot take linear regression, all these things. So just make sure if anything is not clear, please ask that on the spot. Okay, and we can explain. Then else we will move forward, because this kind of in a way actually this completes your logistic regression. After that, all the steps, they are the same as we took in linear regression. That we will be doing a gradient descent algorithm. Okay, so just give me a quick thumbs up if everything is clear. Then we can move forward. Okay, Akshata, I see you have small doubt. What is y a log a? Okay. Yeah, so you should ask this doubt when I'm explaining also. Okay, don't be afraid to ask doubts here. Even if I have to cover some topic in the next class, I will make sure that every doubt gets clear, because that is very important. Okay. So Akshara, first I will explain your doubt. So you are asking on this thing, okay? Y A is actually your Y actual value, okay? So what I am saying is, what I just also showed you is that basically, let's say whenever my Y is 1, so let's say whenever student is passing, okay, whenever I say that hey, student has passed, okay, not passed away, he has passed the test, okay, because we are taking from the starting, we are taking just two values, study hours and if he has passed or not. So what I'm saying is, in that case, my error would be log of y hat. Actually, I wrote this y a because this is y actual. Okay, so this is 1. This value is 1. Okay. Now this log y hat, this y hat value, I told us this y hat value will be this. Okay, and the graph for this is something we saw in on Google also. This is something coming up to be like this. Okay, so this will tell me that okay, what is the error in this value? What is the error? How much is the error when a student has passed? Okay, how much error is there? So let's say if I am trying to train our model, okay, we'll be training it on the, let's say, train data. Okay, we will be training, we have a lots of train data and we will try to find the best value of m and c, or let's say just m in our case. So we are defining the error which we will have, okay, the error which we will have when the student has passed using this equation. Okay, this is what we are using. Okay, so just let me quickly remove and write it separately because I think this might be a little daunting. So I J, and Thomas, I think this will answer your question as well. We are not using the error function from linear regression because it is not convex. We can have a local minimum where we can stuck. I show you the same way using diagram also. In this, what we are considering is that my function, my error basically would be y hat, and it will be log of 1 minus y hat when your y, or let's say when student result, let me write it result here, okay? Result is equals to pass, result is equals to fail. Okay. Let me now explain this in a little bit more depth. So let me try to do that also. Okay. We are using log because the graph is like this. We wanted a convex function. So that's why we have actually Ulhas taken here that, yeah, using logs and basically the error function like this, it tries to give up a convex graph, okay, where the minima is present. So what will happen is, if let's say you have taken some value of m initially, you have taken some value of m. So just I'm basically working on this thing. When your actual y actual is 1, or let's say when your result is passed, let's say you will calculate that, okay, this is coming out to be this. Okay, this is your m. You have taken this and you will see that, hey, I still have errors. What do we mean by error is that there is still a chance that you can actually misclassify the class. I've given you 8 hours and you're saying that, hey, this will fail. Okay, so this might have error. For 8 hours, maybe you are getting the value as 0.45, okay, which is fail. But in the real value, we have passed. So what we will do is, similarly, we will go for each data set, okay? So now, I will calculate this del j by del m, okay? So my changing of m remains the same, by m new is equals to m old minus alpha del j by del m. So my del j by del m, this will actually be kind of in a similar way summation of all my errors. Okay, so your j actually will in that way be the summation of all your errors. So you will calculate this del j by del m for all the points which you have. Okay, for all the points you will see, and when you will calculate this error, you will see that, okay, I can change the value of m, so my error can reduce. It is very similar in a way we use for linear regression. Okay, so the reason we are using log is because this log loss function kind of gives us a convex graph which we can optimize to find our global minima. So that is why we are using the log function here. Okay. So Thomas, this is actually the error function which we have, and the rest of the all the things remains the same only. Okay, where what we are doing is we are just seeing that, okay, what can be the different values of I can start with a value of slope starting May, and then once I move forward, I can keep on changing that based on del j by del m, what is my value. Okay. So if can I let okay, just one thing actually I will write more. So just this is clear. So we saw that in the in linear regression only. So it is actually something like this. I was actually showing you all for the 1 point. Okay. So this is my del j. So minus yi. This is my real result, real value if we passed or failed. Log of y hat minus 1 minus yi log of 1 minus y hat. Okay. So this is my error function which I've written. Let's say I have 5 values. Okay. Student study 3 hours, 4 hours, 5 hours, 7 hours, and let's say 1 hour. Fail, fail, pass, pass. Let's say student passed on 1 hour also. So what I will now do is, okay, what my work here is that I will first, basically this is my error function. Okay. So I will start with a value. So you can think of y hat, we told that we can take something like this. 1 plus e ki power minus mx. We can, let's say, omit the c for now. So now I told that the graph for this function is like this. Okay, something like this. We will start with some value of m. Let us put that value of m, let's say 0.5 here. Let's say 0.71 here. Okay, let us start from 0.71. Okay. Now you will train your model. How you will train your model? You will first take f. Okay, so your result is fail, which is 0. So this thing will basically be, so let me take j1. Let me write it like this. j1, your error. Okay, let me write it here actually, that will be better. So just trying to explain you now very nicely. Please pay very nice attention here. Okay, so that this thing is clear. So now this part, if your fail is here, then this part will become 0 and your error will be log, okay, 1 by 1 plus e to the power minus 0.71 into, how many are the hours? 3. Similarly, in J2, your, okay, I think we have to take 1 minus also here. So 1 minus this, because it is 1 minus y hat. Okay. Similarly, J3 will be, if we see here, this is minus. So for pass, this thing will become 0. Okay, because this will be 1. I will be taking my error as this. Minus 0.71 into 5. Okay. So now I will sum all these errors. Okay. So my error is summation here for all the errors. I was taking a single point till now. Now when I get this error, let's say this value is coming out something around, let's say something around 10 or something. Okay. I will see that, hey, for my 0.71, so this is 0.71, my value is 10. Now I know that my graph, the way I have made my error function, this will be kind of my graph. So now I will do the same thing. I will try to calculate this slope. This derivation will be a little tricky. We can still do that if we try to find del j by del m. Okay, we will have to basically consider the derivation with respect to e to the power minus mx. But still, what you have to do is your slope will still be positive here. Okay, so you know that, okay, your m new is equals to m old. This is your m old is basically 0.75 here. Let us take alpha as 1 only now. Okay, so this is 1 only now. Let's say del j by del m. We will just put a line here. We will take del j by del m. My del j by del m also I will calculate. Okay, this will be basically summation I is equals to 1, whatever is the overall derivation of this function. Okay, this will be a 10 to 15 minute derivation. Okay, I try to not cover those because that will be a little bit heavy on maths for a lot of people. But you can think that, okay, some value we will get here. Okay, and whatever value we will get here, we will put it here. Okay, which will give us our m new. So now we will go to m new. Okay, let's say this is now 0.59. Repeat the same step. Calculate all the errors again. Normally you will have this value. Okay, you will get this value 0.59. Repeat all the same steps. You will get this as 0.59 now. Okay, minus. Now what is your del j by del m? You can think of taking a batch gradient descent, stochastic gradient descent, mini batch. It is on you. Now you will find. So in a similar way, it can jump, let's say here. Now you will basically come like this. So you will calculate all these errors. You will see that, okay, where it is coming, and basically basis on all that is how you will clear all these things. Okay. So I hope this thing is clear. Like I am not trying to show you the full example, kind of revising you the gradient descent also. Okay. So let me know if any doubt is still there. Akshata, Ulhas, and I think someone or Thomas. Yeah. So Thomas, Akshata, and Ulhas, let me know if anything is still not clear. Okay, and we will actually, I think, yeah. So So all of you guys will now want to see that okay, how it actually happens in the real world. So let us go to the code. And also one more thing, guys, if you are actually liking all the effort, the teaching, please like, share, and basically subscribe to the iNeuron challenge. Also share this video with everyone. Like anytime you see have to start their journey, okay, just drop a like here so that it reaches to more and more people. Okay, it would mean a lot because you can see that yeah, we are putting in a lot of efforts. Every mentor here, everyone is putting a lot of effort to make you understand these things. So now this is a quick practical explanation and working of the same. We have the binary logistic regression. Basically, we have just taken NumPy, Pandas, Matplotlib, and we have just from Scikit SQL library, we have imported the logistic regression. We are not writing it as of now ourselves. Okay, so let me just quickly run it. I will try to share this thing with you also. So yeah, synthetic data generation. Someone asked how we can generate the data and everything. So that is where I was saying. I hope this screen is visible. Everyone, can you just let me know if this is visible? This is the default zoom which I take whenever I'm explaining you these concepts on Python notebook. Okay, same data. We have taken the study hours. We have taken if it will pass or fail. Okay, 0 indicates fail, 1 indicates pass. This line you can like ignore as of now. This is just for scikit-learn compatibility. Now we have taken our model. So this is how we actually train in Python model. We have written the logistic regression and we have basically seeing if it will pass or fail. Okay. Now starts the good thing. Same thing how we did in the let's say this your linear regression. We got the slope, we got the intercept. It is basically based on the logistic gradient descent algorithm only. Okay, where we have now got these values, the most optimum values. And now let us also plot this. So yeah, this is something which we are getting here. If you will see that what I have done here is I will actually tell you for each of the study hours. For study hours, I have basically just scattered them. So this was our data, right? 2, 3, 4, 5, 6, 7, 8, 9, 10. Then study as model.predict proba. Okay, so what this predict proba does is, so see, I have this 1 by 1 plus e to the power minus, so we just had one variable, right? Mx plus c. I hope everyone is clear on this. I got my m value, I got my c value. Those were the intercept and training value there. See, these were the values, right? I used them. Now, I just put in my x value, okay? So I see that okay, for 2, what is the value? So value is coming something around here, value is coming something around here. So this is basically I know a decision boundary which I am forming. And just to explain you guys a little bit more, these are actually the probabilities which we are getting. Okay. So for 3 hours, it is kind of doing a miscalculation, not a very optimized data, I would even say. But anyway, the line is kind of fixed. So for till 4 hours, it is saying that hey, there is a 0.36 probability that he will pass. So you can actually take this probability also something like this. What is the probability that my y hat equal 1? So if a probability that he will 1 is basically pass, he will pass is 0.36, that means he will fail. So we do a 0 here. So you can actually, I will share this with you, like every one of you, you can try to calculate this value by yourself also. Believe me, this will clear all the doubts if you do that. Okay. Again, the formula by which this is calculated, sorry, my bad. Y hat is 1 by 1 plus e to the power minus mx plus c. You have the m value, you have the c value from your gradient descent. Okay. Now using this, basically all the study hours, if you're studying 7 hours, this is the value. And we have also plotted the graph for the same. And we saw that, okay, how the graph is kind of, I would say, it is kind of a sigmoid function. It is getting that, right? We saw that, right? That we are graph of y basically will be something like this only. And if you will see that it is coming out on that note only, right? It is going very quickly to 1. Okay, it is going very quickly to 1. If you will see here, okay, this can be the threshold value. This should ideally be the threshold value. So if we see this, let me clear this all. So same thing, all the concept which we studied. This can be a 0.5 value. Let's say I think it is coming around to be somewhere around 4.6 or 7. Okay, towards this is going to 0 and it is not going out here. We saw that, right? So I hope now this should actually be helping you to clear everything. We have made this So the reason that we are using this function, it tries to now converge to this point like this. Sorry for the double line, but yeah, this is how it is happening. Okay. So yeah, this was a very good practical example. Let me just quickly show in the comments if this is clear or not. So just take basically 30 seconds and understand that, okay, what I have just, okay, let me show you this only so that it is clear. Yeah, just have a look and let me know if everything is clear here. That would be very helpful. This is a full practical of everything we have understood. Like I have actually just generated the data here. All the other functions are just used as it is. So it's not like I have tried to fit something here. Okay, and this is the actually kind of, I think, practical knowledge, or let's say the way one should be studied. So after showing you all the theory, I made sure that I have shown you the same thing in practical as well as all these values. Okay, so it is very easy, very important to understand this. Believe me, when I studied logistic regression the first time, I was not aware of any of these things. Like the way I studied, I was just given the formulas. I was not told that, okay, how this thing will cut, how we can calculate probability. Hopefully all of you won't face that issue in logistic regression now. Okay, cool, thanks all. Now let us go back. So the last thing in logistic regression is multi-class logistic regression. So a lot of you had doubts that, okay, if it can be used on multiple multi-classification. So multi-classification, I meant, let's say when we have MNIST data set is a very good example of that. Cat and dog is just, let's say, cat and dog is just binary, but if we add lion also, it becomes a basically a multi-class. Okay, so now one thing is very important to understand. So in we actually, I just saw that we can take this as a probability that, let's say, y equals to 1. Okay, whatever my proba was giving me, or whatever this thing will give me, e to the power minus z, whatever this will give me, this we can take that as a probability. Okay, now, and we have also seen that my y hat now can be 0, 1, but it can be other values as well. Okay, so the thing is that the whole maths which we have seen in the previous slides, the example which we have seen, that is actually not how I would say we can integrate multi-class thing into that. So it is not that we have some error function where we are making, let's say, y is equals to 0, then take this error, y is equals to 1, then take this error, y is equals to 2, then take this error. This is not how we do that. Okay, that integrating this overall math basically becomes very, I would say, cumbersome and very problematic. Okay, then we'll have to come up with functions for all. It actually also converge into a problem. It might be non-convex. So these kind of things can happen. But what we can do is we can do 1 versus rest. Okay, we can do 1 versus rest. Okay, so let me now try to explain you this also with an example. Okay, what we will do is, let us say we have 3 classes. Okay, let us take 3 classes. The first one can be, okay, let me take the classes which are more get by you. So let me, anyway, I think we can take in this way only. So let's say there are 3 classes: pass, reattempt, and fail. Okay, so let us say these are our 3 classes. A student can pass, he have to either reattempt or he can fail. These are the 3 classes. We have seen already on pass and fail, so I hope this example would be very clear to get. So we just saw that, okay, there is no, okay, I just let me take data also. So let's say 2, 3, 4, 5, 7, 8, 9, 10. These are my study hours. And my result is fail, fail, reattempt, reattempt, pass, pass. So it's a difficult test. Students have to study more than 7 hours for this. Okay. Now, to use logistic regression the way we have studied, okay, what we can do is, so let us take it in steps. Okay, let us first take the pass one. Okay, what we will say is, if a student has passed, okay, so what we can do here is, this is 1, 1, 1, 1, and anywhere if the student has not passed, I don't care if it is reattempt or fail, I will just take 0. So this is 1 versus z. I have taken passed, I have taken if he has passed as 1 and all other as 0. Now I will train a logistic regression model. Okay, so I will get my probability of, let's say for a particular, let's say if I let me write this y as pass here. Just don't. Okay, let me write it like this. Okay, so I will train my model in a similar way now. Okay, everything is same. Everything basically is just on the similar lines, and I will let me say this model is logistic regression model 1. I hope you now get the intuition overall. Okay, the intuition that okay, how I will be doing this. For reattempt, similarly 0, 0, 1, 1, 0, 0, 0, 0. Py is equals to reattempt. I will name this as logistic regression model 2. So why I am doing all this? So let's say if I get a value tomorrow, let's say 6. Okay, I got that. Okay, hey, you have all this training data. Now let me know if what will happen if student has studied 6 hours. So I will have to actually make these 3 models and fail. So very simple to understand. Fail is now this. This will be LOR 3, my model number 3. Now whichever, so one thing, 2 things to understand here. The probability sum will not be 1. These are 3 independent models. Okay, don't be like, okay, this is the probability exactly and this is basically what exactly will happen. So let's say it is not based on that ratio. It is just telling you that, hey, in my 1 versus test model, this is the chance that this person will pass, fail or retest. Okay, so whatever the value is maximum here, you can take and assign that value. So let's say for 6 hours here, okay, whatever the value I'm getting as maximum on these 3 models, this probability sum will not be 1. Okay, I can then take that value. Okay, all these are independent logistic regression models. Don't get confused and don't be like, hey, these probability will be 1 and they are giving you individually that what should be the pass, retest or fail thing. No, it is not like that. It works on 1 versus rest thing. Okay, we can make it 1 if like let's say summation to 1, but we will have to divide them by the sum, I think. So if we divide all of them, yeah, if we divide all of them by sum, then we can basically get that thing. But then this won't be the probability kind of. Okay, so whatever is the highest of this, so basically max of these 3 probability will be my answer. Okay, whichever probability is giving me the maximum value, I will take that. Yeah, this is how we can use multi-class logistic regression. Okay, I hope this thing is clear. Okay, a lot of people say that logistic can only be used for binary. That is not the truth. We can use that for multi-class. This is one of the way, 1 versus rest. Okay, there are other ways also, but I think if you know this one, it is more or less fulfilling. That how you can actually use one of the way does normally good. And I can actually also tell you show you one more thing just to show that okay, this thing is used. Because like when I understood this the first time, I found that this seems to be a lot easy to be true. Okay, like this seems to be that okay, are we actually doing this, that we have learned one model and we are doing this? But somewhere there must be something. I think 1 versus rest. Yeah. So see, multi-class, it is asking us auto, OVR, 1 versus multinomial. So multinomial is actually another one which I'm aware it's a little bit comparatively a little bit more complex. But yeah, Akshata, we will train it separately. So OVR is there. OVR is 1 versus det. And see, this is a default even. So if you give it the iris data set, okay, it will actually use this OVR only. So Akshata, yeah, we will be doing this 3 models, LOR 1, LOR 2, LOR 3. This is how we will be doing this, and this is how actually we get the answer. I hope this is clear. I have kept this also very intuitive, and this is actually how it is for basically done. I've shown you that even this is a default setting. Understood that this easy thing is the default. So how much it will be used, right? Thomas is asking, classify that output max probability selected. Yes, Thomas. So if you will see, we have just changed this to 1 here. Oh, nice, finger also works. So yeah, we have changed all this to 1, 1, 1 here. So this actually are now giving me probability of pass. 1, let's say this is the 1 for this is the 1 for this. And I also told you how we can consider this as Py equal to 1. So we have trained 3 models. Okay, and now based on whichever is happening the highest, we can actually use this. Okay, I hope this thing is clear. Like this is one of the way we handle multi-class in our basically logistic regression. Okay, this kind of complete your logistic regression. There were few. I think the last thing which I had in mind was the metrics. But I think on the time, yeah, it is 1:55 is already, like, it has been 12:55. So we can maybe cover this in the next class. Let us not close this out. Let us cover the classification metrics basically in the next class. It will be better. Meanwhile, yeah. So in the next 5 minutes, if you guys have any doubts, feedback, anything, you can write it down. It took a lot of effort to actually explain and create notes like this. There's a reason I don't write a lot on my slides, because once you write it, you have to explain that in this way, and basically that thing comes into the mind of other person. And I want to intuitively, like, make you guys walk to that implementation with me. Okay, that's why my slides are actually clear with just the thing. Otherwise, it is very easy to just write the, I would say, formula on the slides and then explain that, and not write that formula 10 times, which I have to do. But yeah, I hope this thing is actually helpful. Okay, we will cover the next algorithm. I will see if it can be naive Bayes or decision tree. Okay, based on the next class. Before that, we will cover the classification metrics as well. Please enroll into the class. Drop your like and share on the YouTube video. Okay, you can also follow me on LinkedIn and just write whatever feedback and everything which you have. That would be a very, I would say, very good motivation for me. Okay, how will we calculate probability of retake case? Okay, so it is actually on the similar lines, LinkedIn user. So let's say, okay, let me use red pen. Let's say these, 1 second. Just give me a second. This actually tends to, okay, now it is fine. So both of our pen are right. So if you use a dark screen, that will be more visible. We'll do that, Akshada, but actually I think in the dark, overall we have some issue. That's why we use white only. So we see some pixelating and everything. I will try to see and check that. Okay, normally the thing is that this pen, if you will see, we also don't have white here. Okay, so in that way it will be a little bit problematic. That's why we prefer like white screen and black here. I hope this is visible. I will provide you with this thing and you can see in the recording. Okay, I think it is recorded in 1080p or 2K, so that should be easy. But the reason for not using white is that I normally feel more comfortable in using white pen on black. Okay, so that's the stuff. Maybe let me see if I can check something, but let me first clear the doubt. Okay, so the next thing is how will calculate probability retake case. Yeah, so see, this is my data. Okay, what I'm saying is just consider is that if it is a retake or not. I don't care if it is pass, fail, backlog, anything. I don't care about this. Okay, so we will just take all retake as 1 and just other retake as 0. Now this in a way become your problem. This is a logistic regression problem where we see pass or fail, or the way we have seen in this whole class. Okay, so you will just change your model normally. Okay, you will tell them that hey, this is the one, this is where it was 1 and this is the other thing. Your decision boundary, your logistic regression will learn the everything in this way only. And once it is done, it will, you can actually take that, okay, what is the P probability y is equals to 1 or retake, and your logistic regression 2, if let's say this is the second model, it will give you what are those probability. Okay, I hope LinkedIn user this was clear. Can you just please give me a quick yes? Charan is asking, can we get a job with a good project only using machine learning, not having knowledge of DL or Gen AI or NLP? Charan, that will actually depend a lot on what kind of company industry you are going through. For example, honestly, not a lot of these NLP, deep learning and AI concepts are used in the most of the industry. Okay, in most of the entry-level analyst or let's say data scientist job, this is not the use case. That said, it is very, I think it becomes a little important if you're going in any product-based company. The reason is that if I take my example, when I joined Oyo, ideally one will think that Oyo will come on examples on, let's say, booking, non-booking, price and all these things, right? But the very first project which I got, it was the first project, so that was based on NLP. So the issue is that in product-based company, those kind of things happen where a lot of data is getting generated and data is of all kind. I have even done a project on images, so there the help of deep learning was used, because any product-based company, like let's say comments are there, images are there, all these kind of stuffs are there along with data, and data is there in every company, like those Excel kind of a data or data which we are using in this, which we can get through SQL. Okay, so on that way, Charan, I think it is suggested, but that said, if your goal is, let's say going strictly to a company where you know that these kind of problem won't be there, then I think it is not that big of a problem, and many companies are there like that. But I will suggest to learn all of these things with me. I will try to basically explain you NLP and other stuff also in this way only. Okay, I also will be having a course in iNeuron, and basically will try to like do these community classes for other concept as well. But I think then that should be clear, and even having an entry level intuition level idea, that will be very helpful to you. Okay, so you can maybe just follow that. Okay, and it's better if you have that. Maybe you can say you have not done any hands-on project, or let's say like experience, like relevant industry projects, but you know what it is and you are willing to learn. Then I think it is helpful. Okay. Cool. Let us take. Thanks, Akshata. If gap is 6 years, is there any chance you can get the job? Yes, Ulhas, that can happen. You have to just work a lot on your skill. You have to make sure that you are able to explain that why you are not able to, why you didn't work for 6 years, and your skill should actually be on the, let's say, at a level where now it is after it's like, so for example, you should be now knowing all this thing, and your company should also be looking for a similar thing. I always feel that your experience counts. Okay, so if you can say that okay, in the 6 years you have done something which is helpful, or let's say which can help a company, that should be doable, like easily doable. But yeah, you will have to put in the effort. That thing is for sure. Depends on the requirement of the job opening, but mostly organization cost cater to different kind can hard. So that is right. Anand Usharani is asking, I have a gap of 8 years gap. Can I get a job as a data scientist? Yes, you can, Usharani. It might be an entry level job. You will have to understand a lot. You will have to, I would say, compete with candidates who have experience, industry experience, and all this. But that said, it is not the case. In our project, in our courses, we try to basically include all the case, like let's say projects which are industry level case studies. So using that, I think it should be doable. And the best is basically, yeah, make sure that you are putting in the effort, right? Just thinking that you won't get anything will, of course, not take you anywhere. So yeah, I think we are already over time. So just last question: how to pay for data science beginner position in the checklist? Actually, I will try to start a community session. I normally don't believe a lot in checklist or roadmaps. I can actually try to give you a roadmap, but that should be, even I should be aware that okay, if everything I'm mentioning, that should be like, see, it is very easy to write something in roadmap, okay, but then when someone has actually do it and see that okay, if it is being used, that is I think where the major thing lies. So I can try to provide you with a roadmap and let's say all these things, but I will try to do that in the starting of, if I start with community classes for data science, okay, that I think will make much more sense. I can just take 10 names right now and you will then waste your time. What I will suggest all of you right now is just to understand this thing which we are doing, because this of course is one thing which you need to understand, and then we will cover all the other things as well. Okay, cool. So yeah, I think we can then close this class and we will meet in the next class. Thanks a lot everyone for your attention. Just go through the recording again, enroll in the iNeuron website, please like, share on YouTube, and yeah, just should be fine. Okay. Yeah, okay, cool. Thanks a lot everyone.